Hey guys, today we're going to be looking at this seemingly difficult AMC problem, which actually could be really easy if we just use this one trick. Now, the problem asks what the remainder of this large expression with 2's is divided by this quadratic looking expression. Now, obviously we can't brute force this and try and find the number here. So the next way we can do this is using the Sophie-Germain identity. The Sophie-Germain identity basically says that if you have a number to the fourth plus 4 times another number to the fourth, that equals that number squared, which is basically the square root of that, plus that number square rooted, so 2b squared, plus 2ab, and then you just multiply this by the same thing except you change the 2ab to a minus 2ab. Now to truly memorize this formula so you're able to apply it in your further problems, I just use the method I just explained there about taking the square roots and then just adding a 2ab and a minus 2ab, since that actually helps a lot. Okay, let me write this in a smaller area so we can actually solve the problem. So you're probably wondering how we applied this formula, which has all these variables, to this problem, which has all these numbers. And the way we would do that is looking at this 4b to the fourth term. Now 4 is the same as 2 squared, right? So we just have 2 squared b to the fourth if you just want to write it like that. Now you might start to see a relationship between this number and this number right here. Basically, what we can do is we can let b equal to 2 to the 50. And what that lets us do is that lets us simplify this. So we can just make that 2 to the 2 squared times 2 to the 200 plus 202. And 2 to the 200 really is just if we just let b go to the fourth, b to the fourth is equal to 2 to the 200, right? So we can just do 2 squared times b to the fourth plus 202. And this becomes 4b to the fourth plus 202, which is what we had right up there. Now, you're probably wondering how we're going to use this 202, and I'll get to that in just a sec. But for now, let's convert this as well. So 2 to the 101 would be 2 times 2 to the 100 plus 2 times 2 to the 50 plus 1. And simplifying that, we get 2b squared plus 2b plus 1. Now, the main trick here is I want you to notice this number and one of these numbers. So if you don't already see it, what we can do is we can make that go to 4b to the fourth plus 1 plus 201. And if we simplify this using our Sophie-Germain identity, so basically from here what we can do is simplify and get 2b squared plus 2 times b, so 2b plus 1 times 2b squared minus 2b plus 1. Now let me rearrange all these terms so that it becomes pretty clear. If you need to, pause the video right here or go back in the video so that you can see the steps again. Okay, so now that I've rewritten it, you can see clearly that we made this 4b to the fourth plus 1 into this expression. And if we add the 201 at the end, that's our final expression for this. Now, we need to find the remainder when that's divided by this. So what we can do is we can separate this term into two parts, basically dividing it down the line. And then find the remainder of this, and then find the remainder of this. Now the remainder of this is just 0. And the remainder of this is 201. So we just add them up again, and our final answer is going to be 201. And that's it for this problem. Now, if this problem is kind of complicated, I'll go back in the video and rewatch how the Sophie-Germain identity was actually applied. But other than that, that's it for this video. Please be sure to like and subscribe down below. Check out my latest videos covering the AMCs and how you can improve in your math competitions. But until then, stay crazy.